So if you're looking at that one there, it says a chorus line and Beauty and the Beast. So knowing me, for a chorus line, what variable do you think I'm going to use?
I use C.
C, I like it. And Beauty and the Beast?
B.
B. I like it. Cool. And what does that really represent, though? What does that really represent? What is it that I really don't know?
The number of performances.
Beautiful, right? The number of performances. Now, I know one level of this is that we're not terribly interested in some of this stuff. I'm trying to every now and again inject into the class examples of how this is used in real life. So you got to get past that. The second part is when you write these down, you really have to understand what they truly represent. In this case, their number of performances. Why is that important? Because if they tell me, so the number of shows, if they tell me a total of 11,598 performances, that is a nice, easy equation to set up. Since this is the number of chorus line shows and this is the number of Beauty and the Beast shows, and there were a total of 11,598, what equation can I set up?
C plus B equals...
Yeah, this shows plus this shows equals 11,598. A lot of times people write down variables, but they forget what the hell they mean. And then how can you go to an equation when you're not even sure what C and B mean? You put the wrong things down in the wrong place. Number of shows. If you add them, you should get the total number of shows. Now the other equation on this one is a little weird. It says 676 fewer performances of Beauty and the Beast than there were of Chorus Line. So which one were there more of? Chorus Line, right? So how do I set that up then? Beauty and the Beast is Chorus Line, but it's how much fewer or more?
Minus.
Beautiful. It's fewer by 676. So on one level that was, you don't see that all the time. You don't see one of your equations being one is less than the other one. But do you see why that's really nice? What method has that set itself up into? What method? Substitution. B is this. Plug that there. That's nice. The next step is now easy, right? But you see that one key step there was for me just to take a second, just to make sure I wrote this down right. I had to think, which one were there more of? There are more Chorus Line. There are fewer Beauty and the Beast ones, right? So this makes sense. I have to subtract something from Chorus Line to make it Beauty and the Beast. Because there were fewer Beauty and the Beast. Okay, so then what do I do with this here? The rest of it now should be not too bad. What can I do with this expression here?
Put it where the B is.
Yeah, put it where the B is. Because that's what B is. Okay, cool. So obviously fewer should be some kind of subtraction. The mistake that people make on this problem is they subtract it from the wrong one. Just take a second and say, which one should there be more of? Which one is there fewer of? There's fewer Beauty and the Beast. So that's why I should take that away from Chorus Line to make it equal to Beauty and the Beast. Okay. Maybe. So if there were 7 fewer men than women,
Woman equals men minus 7.
now here's where we got to be careful. Which one is there less of? Men. There are fewer men. So how to get men? And what do I have to do to the number of women to get the number of men? There. See, that's that key step. That's the step that you guys don't even realize you can do sometimes, I think. Step out of the math for a second. You say, what the hell makes sense? How can you interpret if this makes sense? Well, there are fewer men. Okay, this makes sense. I have to subtract 7 from the women to get the men. There's fewer men. Makes sense. A lot of times, students don't realize they could do that, or you skip that step, or you don't care. Right? And I don't blame you too much for not caring, but I'm always desperately trying to show you how mathematics works in real life. Right? We desperately need to know how to do this stuff to do almost anything. Believe it or not. Not buy a head of lettuce. Right? Like say I had a student once said, "Oh, this help me go buy a head of lettuce." I don't know. Shit. How does history help you go buy a head of lettuce? How does any of that stuff? That's not the purpose of these things. It's beyond that. So you guys can finish that out here, right?
Mm-hmm.
C plus B, but B is C minus 676. And even though the number's big, you don't care. That's a really nice equation. So I'll let you guys finish that out. Is that cool?
Mm-hmm.
Okay.
Yeah, I like it.
So don't forget, you can very often step out of the math and just say to yourself, this is a sentence. If you take 7 away from the women, you get how many men there were. There were fewer men. Cool, that makes sense. The math makes sense. Any other questions? No more other questions on homework? Is it weird? It's not like saying A and B. It kind of goes along. All right, okay. I am an optimistic fool, so I'll take that as a good sign. So don't forget, you've got my office hours. If you want to get as many points back on corrections as you can, I'm not sure why you wouldn't come see me before you officially turn them in. Come see me and say, take a look at these. Can you see anything still wrong with these? Something still wrong here, something still wrong here. And if you sit down, it's my office hours, I'll help you with it. I will be your tutor. Right? Can't beat math teacher as a free tutor. Holy shit. So please, dear God, don't make the same mistakes. I hate giving back corrections and I haven't given any points back. I just box off the old score and say still this. Because they're all still wrong. That doesn't make any sense. Don't do that. Take full advantage. Right? And in general, just come see me if you have trouble with the homework. If you're not doing the homework, you're not having any trouble with it. But that itself is a problem. So please, dear God, please be doing the homework. That's why I'm trying to be optimistic right now. There are no questions, so I'm going to assume that means everyone's doing the homework and it's going great. That's me being silly. So we finished out chapter 4 last time. So if you weren't here last time, let's just do a couple quick problems from the last part of 4, and then we're going to get right back into 5. Obviously, we just did one from section 4.4, which if you weren't here last time, you see that that's another word problem section. Those word problems are nowhere near as difficult as the ones back in 2.4 or 2.3, whatever it was back in chapter 2. They're a lot more easily set up. So if you were here last time, I hope you agree with me. If you weren't, take a look at the video or come see me. All right. But I do want to look at 4.5 real quick.
We finished 4.3, didn't we? That was for the test.
That was before the test, yeah. Let's make this. So just really quickly, just to make sure that everybody's on the right page. This is actually old stuff, just twice over. So this would be section 3.5, if I remember correctly, right? At the end of that section. This is section 4.5, where you have 2 of them at once. So if you can do 1 of them, you certainly should be able to handle 2. If you can't do 1, you're obviously not going to be able to do this section. Right? But how do I do this? What's the way that I'm trying to get you guys to do this? What should you do first with each of these? Solve for y. So here, what would you do to solve this for y?
So subtract x. Divide by 3.
Divide by
Negative 2.
-2.
So is that when you switch the sign?
Beautiful. If you divide or multiply by negative, that sign has got to switch And here I get positive 1/2 x minus 3. Cool, so there's the first equation. Solve for y. And this one, of course, is nice.
Minus 3x.
Beautiful. Subtract 3x.
So you flip side when you divide by a negative.
When you multiply or divide by a negative. Cool. Okay. Now go ahead and try to do that. Go ahead and try to graph number 1. If you weren't here last time, just take number 1 and graph it. And that involves shading. Right? That inequality means you're going to have to shade. The only new thing now in this section is you also graph number 2 on top of that. You're a relation, or are you just interested?
Just my
Friend?
friend. Yeah, just he's not doing
All right. You know what that says? Anybody else not get their stuff back yet? Their test? Oh, sure. Well, that's how many A's there were going to be overall, and this is how many A's would be in the test.
I'm just making sure there's no funny. This is 0 is whatever the other number that's like.
Sure. So you set up an appointment? You got my email? Okay, so check your email. I give you the phone number to call and make an appointment. All right, let's see. So number 1, what's the y-intercept? -3. And the slope tells me to go up 1 over 2. What kind of line will it be? Dotted, just like, or dashed, whatever your favorite word is. Just like an open circle. That represents I can't include the points on that line. So technically those should be open circles, but I don't care. As long as your line is dashed or dotted, you're fine. This guy, what's the y-intercept?
Are you gonna shade it first?
Oh yeah, I'm sorry, I keep doing that. How do I tell which side to shade? Which way do you guys?
Test point.
Test point. So if you plug in 0, 0, is 0 less than 0 minus 3? Is 0 less than -3?
No.
No. So which way should you shade?
Down.
Away from that test point, so down. Those of you who understand the shortcut, less than, down. This guy, the y-intercept is 5. And the slope tells me to go
Down 3.
down 3. 1, 2, 3 over 1. What kind of line will it be? Solid. And again, if I plug in the test point, is 0 bigger than 0 plus 5? Is 0 bigger than 5? No. So I'm going to shade away from there. It didn't work, so it must be on this side. I like it. So where's the answer?
In the double shaded.
In the crosshatch. And so you just take a second. I like it. Take a second and make it a little darker in there so I can see. So that's the region of points that all work in both inequalities. Cool. So again, the real life application of this is you have a situation where it's an elevator, and how many things can you put on the elevator before it plummets, or it's wire, how much current and how much whatever else can it take before it explodes or whatever. You have these constraints on your situation. You want to know where is the safe zone. That's one immediate application of this type of thing in real life. Okay, cool. In real life, the lines might not be lines. They might be curves, but it's the same idea. You draw the curve, you draw another curve, you see where they overlap, and you're there. That's where you want to be, so you don't blow up or whatever. Right? So math keeps you from blowing up. Okay. So, I mean, that's a really good example of a lot of different skills. Can you graph a line? Can you understand what the inequalities themselves mean? So all these little extra skills, they all come together in one problem. So if you have any trouble with any of those things, you're not going to be able to do that problem. So this is where I desperately need you to come see me so I can identify where it is you're having trouble. It could be any of those little things that go into that problem. Okay. So, getting back into what we did last time, a quick little review. Red pen. So remember, the whole idea of exponents, it had to be thought up. It's really just a shorthand way of saying something. So, if I have that, I really don't want to have to write that over and over and over and over again. So what's the shorthand for that?
X to the power.
Be careful. I know I put the title exponents. This is obviously just a preview thing.
X to the 6.
Yeah, when you add these, you get 6x, of course, right? So the analogy is, if I have this, all right, so you guys are getting a hell of a lot ahead of yourself, but I understand. I was a little mean. Some dude or dudette already put the 6 out front, and everybody agreed with them. They got on the phone and said, dude, the 6 in front means 6x is adding. And they're all like, sounds like a good idea, Chip. Why didn't I think of that? But then this person on the other side of the earth is like, damn, they came up with that. I wanted to put the 6 in front to mean multiplying. Shit, I got to put the 6 somewhere else. I'll put it up there. And then everybody agreed, except for one guy that killed him, and then it's all good. Right? That's the rough history of mathematics. But one thing I want you guys to realize, a lot of what we do in here, the idea doesn't change, but the way that we represent it is not the way it had to be. So it's kind of good to know that. At the same time, you got to learn this way, because that's the way it's been done. That's the way it's accepted. But it's nice to realize math is not set in stone. There's a lot of different ways to represent things. And it's just somebody said, let's do it like this, and nobody else really thought of a better way. They're like, all right, what the hell? Sounds good. Kind of like how it happened. So every single property of exponents comes from this. Comes from somebody being lazy. Saying, screw this, let me just write this. Do you guys understand when I write this? That when you see this, there really is no 6 there. There is no 6 there.
It is showing you how many X's.
It's just showing you how many X's. I love it. So that's why people always freak out when I say, like, this. And they say, well, why isn't it 36? You're squaring a 6. I'm not squaring a 6. There's no 6 in there. I'm squaring 6 X's. So what does square mean?
2 of something?
2 of them.
Oh, and is that what you do?
And how many there would there be then?
12.
12. You with me? So the mistake we make as humans is we say, you square something that's 36. Leave me alone, teacher. I don't know what the hell you're talking about. But what I really want you to realize is that 6 is not a 6. It's just telling you how many x's there are in a row. It's not a real number 6. It's just saying there's 6 x's in here. So 2 groups of 6 x's is, of course, 12 x's. Right? So that's why the shortcut, don't do this. The shortcut is just multiply those. Right? Now again, it's real easy to make a mistake. Trust me. I've done it myself. When you're going real fast through something, you'll say x squared times x cubed is x to the 6th. But that's wrong. What should that be? X to the 5th. And again, it's our brain taking over. Our brain saying, when you multiply 2 and 3, you get 6. And then you say, no brain. There's no freaking 2 and 3 in there. There are 2 x's, 3 more x's, therefore 5 x's. Cool. How we all doing? All right, I like it. Good, good, good. My favorite phrase. So real quick, just a rundown of some of these other things. What about this here? Now this is a lot like believe it or not, because remember, what are coefficients based on? I won't say multiplication because it's not true. 6x meant 6x is doing what? Adding. So coefficients are based on addition. So coefficients play well with addition. This is an easy problem, right? Because I have a coefficient in front of something being added. What property do I use? Distribution.
So it's the same thing with the exponent, would you?
Yeah. So watch up here. I do the same thing. Exponents are based on multiplication. Therefore, they should play well with multiplication. And in fact, you distribute it the same way. That's called power distribution, believe it or not.
So you get x to the 6th.
Yep. So x to the 6th. Interesting analogy. Y to the 9th. Interesting analogy. Cool. You guys with me a little bit? Yes, ma'am.
So if they're not in parentheses and they're being multiplied together, you add the exponent?
If the y, am I able to do anything with this inside? Or this at the end here? Why can't I just make it 15?
Because they're different.
Because they're different bases.
Oh.
If they're the same base, then I'm able to put them together, right? Because if I got 3 x's and 5 x's, I got 8 x's. I just put them together. Here I got 6 x's and 9 y's. All right, I got 6 x's and 9 y's. I can't do it. Just like here. Can I put those together?
No.
No. They're not like terms. So with exponents, I need like bases to be able to kind of accumulate them, right? All right, how are we doing support?
Makes sense.
I like it. So I much prefer trying to get you guys to understand why things work the way they do, rather than just, there's this property, here's this property. I'm hoping it's easier to remember if you're just like, well, it just freaking makes sense. That's the way it works.
But this operation is not the same.
This is the analogous operation. This is distribution over addition. This is distribution with powers, right? Okay. All right. Hopeful. What about, who remembers what this was here? It's 1. Yes, it is 1. All right. Because last time we did this whole thing, isn't that x to the 0? 4 minus 4 is 0. Because when you divide, you subtract. But isn't anything divided by itself 1?
Yeah.
So that means x to the 0 must be 1. And again, if x to the 0 was 0, what would happen if I multiplied something by it?
0.
Should come out to be 0. But what is x to the 0 times x to the 7th?
0.
X to the 7.
0 plus 7 is
Oh, you add.
7. Properties cannot change. In fact, how about this? Let me see if you guys can do this. What's x to the a times x to the b?
C. No, I'm just kidding.
I like that.
AB.
What is it?
XAB.
XAB.
XAB?
No. What do you do with exponents when you multiply?
the
plus
X
B.
plus
You add them.
Plus-
X to the A plus B.
Oh.
Right? That is a little evil, but not really. That the property does not change.
What is property? What is
The
that?
property is when you
Is it
multiply
exponent?
like bases, you add the exponents. Just like we did over here.
Okay.
And again, this is x times x. This is x times x times x. So how many x's do you have now?
Oh, fine.
5. So what's the shortcut?
Multiply.
I don't want to write all this
You
out,
add
especially if it's
five.
x to the 200th and x to the 347. I'm not going to write that x's
You
out.
add
I'm just
five.
going to add the dumb things, right? Because that's what happens. Keeping track of how many x's, if I always think of it as like a chain link. 2 links, and then I'm adding 3 more links, so of course now I got 5 freaking links, right? That's why I add exponents when I multiply these things, like bases. Okay. Cool, cool, cool.
Are we gonna deal with numbers instead of X's?
Definitely.
Oh, boy.
Right now, just for properties, we're dealing with x's. You're right.
Oh, boy.
What about, who remembers what x to the negative power was? What's a negative power mean?
1 over X.
1 over.
There you go.
So this would be 1 over x. Okay.
Oh, because you flip it, right? That's what you said?
Beautiful. Negative power
means
means flip. That's all. If it's on the bottom, put it up top. If it's on the top, you put it on the bottom. No magic thing. Negative power doesn't mean make it negative. Negative power only means flip. Yes, ma'am.
So if that was like X to the negative 20th, we would just put
I like it.
20 over X?
No.
Oh. Now what?
I don't know. Let's see. X to the negative 20th. What do I have to do to x? What's this tell me to do with it?
Flip?
Flip it. And what's this tell me to do with it? Raise it to the 20th power, right?
So is that 20 over X?
No.
Or what I thought.
Wait a second.
1 over X.
1 over
It's 20.
x to the 20th. That's what it is. And again, now watch. Stay with me now. Here's what's really going on.
Oh god, sorry I picked 20.
Yeah, man.
Isn't that the same thing?
Yeah.
So, are you with me? Because what's negative 1 times 20?
20.
Negative 20. Alright, so this is the same thing, but now I can see it's telling me to flip it and then raise it to the 20th power. Isn't that what it's telling me to do? So that's why it ends up being this.
What are we flipping?
Because it's a negative power. Negative powers mean flip. Yes, ma'am.
Can you show this last one? I don't quite remember. What happens when you do the negative plus positive and the exponents? Like the negative x to the negative 1, then plus x to the 8. I don't know, something like
Times x to the 8th?
that. Or adding or whatever we were doing right now. Yeah, times.
X to the 7?
Now what do you do when you add a negative to a positive?
Yeah, again, I desperately want you to get this. I don't care what numbers I plug up here. What's the property when I multiply like bases? Add the exponents. That doesn't say add the exponents if they happen to both be positive and no. It just says add the exponents. So if they were fractions up here, I would add the fractions, which means I'd eat like denominators. The property doesn't care what's up there. But once I try to apply the property, I care how do I add these things together, because that's what the property is telling me to do. So what would this be?
X to the 7?
Yeah, because negative 1 plus 8 is 7. Now watch this. What is, here on a totally unrelated note, not really, what is 1 over x times x to the 8th? How many x's cancel?
Just
2?
How many x's cancel? 1. How many's left?
7.
7. So you guys see that? 1 x cancels, so you're left with 7 of them. And what is x to the negative 1 power? 1 over x. Didn't I get the same answer both ways? So a negative power, let me see if I can get you guys to go with me on this. What is 3 cubed?
27.
I like it. So what is 3 to the negative 3rd power?
Negative 27.
Nope.
No, positive
One
times
over
negative.
Nope.
1 over
1 over 9.
1 over 20.
1 over 27.
1 over 27.
Because again,
Oh, okay.
what things does the power tell me to do? It's negative, so I have to
Flip it.
flip it, and it's a 3rd power, so I have to raise it to a 3rd power. So you can do this in steps. This is 1 over 3 cubed. Because at this step, what have I done? I've only flipped it. What have I not done yet?
Doesn't
The
matter.
third power. So what's the next step? What's 3 cubed?
27.
27. So I really want you to notice this. If 3 cubed is 27, 3 to the negative 3 is 1 over 27.
Why do we flip it? What, do we not want negatives? Is that the deal?
So there's more to it than just that,
Okay, just-
right? So recall, if I want to investigate x to the negative 1, and I do this, and I know I do this, and you just have to suffer through this with me. I really want you to understand why this is. If you just memorize it and never forget it, that's beautiful. Personally, I hate memorization. I want you to understand why the hell it is the way it is. We didn't just say, I think it looks better that way. No, it's the way it is. How do I get this from the division rule? What would have to go down here to make 2 minus what is negative 1? Yeah, 3. You with me so far?
Yeah, yeah.
Because when I multiply, I add power. So when I divide, I subtract powers. Because when I divide, I'm losing some of them, right?
So when you get an x over an x with exponents, just subtract them and then that's.
Exactly.
Let
Okay.
them cancel out, right?
Yes.
Okay.
So how many cancel here?
2 on top.
2 cancel, leaving you with
1x.
where?
On the bottom of the
There you go. So what have we just proven?
Wait.
X to the negative 1 equals 1 over x.
If there's one
That's
x
just the
left
way
on the
it
bottom,
is.
why is there a 1 on top?
What are you left with? X divided by x. X divided by x is
0.
1. What is something divided by itself? 1. You with me? That's why there's a 1 left up top. What is 3 over 9?
A third.
Why is there a 1 up top? Because 3 divided by 3 is 1. Right? Nothing changes. Nothing ever changes. Why is there a 1 up here? Because that's what's left when you divide these x's out. Nothing magic, nothing amazing. That's just what's up there. Right? In fact, what's always understood to be in front of something? A 1. So who's the only dude left alive up here? The 1. That's another way to look at it, if you like. Okay. So, if you look at it a different way, if I have 3 squared times 3 to the 4th. 3 squared is what? 9. So 3 squared times 3 to the 4th is going to be big. You with me?
Yeah.
In fact, what is it? Not use properties of
Did you do
exponents.
9 to the 6th?
Careful now. This is why I did this.
Damn.
Are there any 9s up here right now? No. In fact, exponents just tell me how many of these things I have to multiply eventually.
Is it 3 to the 6?
Yes. Because there are, how many 3s do I see? 6 of them.
6 of them.
2 of them here, 4 of them there, 6 3s there.
Okay.
So very often, if you say 9 to the 6th, I understand where that came from. But do you understand why I have to say, I don't see any damn 9s up here? How could you suddenly have 6 of them? Because when I write exponents, am I actually multiplying anything yet?
Not yet.
No. I'm keeping track of how many I have to multiply eventually. So I'm still going to have some number of 3s, just more than I had before now, right? So how do I make a number smaller? I don't multiply, I divide. So if I have 3 to the 4th, I have to divide it to make it smaller. But what does this do? What if I put that there? What happens? What is it? 3 to the what now? 2. Didn't it get smaller? So isn't negative powers acting as if it was division? Alright, I just really want you guys to be with me. Now watch. What is 3 to the negative 2? What is that really? How can you rewrite that? 1 over 3 squared. So how many 3's cancel? 2 of them, leaving you with 2 of them. So a negative power is dividing. Why? For 2 reasons. One is this proof. The other one is the negative power is going to make you lose some stuff. And division is what does that. If I divide stuff, I lose it. So that's not a proof, but that's a reason. A negative power makes me have less. Well, what's the only thing that makes me have less in this case? Division. That's when I start losing things, right?
But you would just subtract it if you like that. Like you
Exactly. This is just explanatory as to why negative means flip.
makes sense.
Because it is division there. Cool. Maybe.
But if you remember just to subtract it, not have to worry about that.
Exactly. So, What do you think about this here?
Oh my gosh.
I think you're mean.
Totally neat.
So you flip it and do something.
So what two things do you have to do to this -4? What two things do you have to do? Flip it.
16 in the denominator?
Almost, not quite. I've got to flip it and square it. So what do I get when I flip it? I haven't squared anything yet. What do I get when I flip it? That comes up, so I get this. A negative power means flip. What do I still have to do? Square. So what's -4 squared? 16. All right, let me take a step back here. Let me see.
Would that be, I mean, if the negatives weren't there, would it just be the same, like?
If the negatives weren't there, there's no reason to move it. The negative power is what makes it move. In fact, if this helps, don't take this. It's not bad to have a very simplistic way of remembering something. If it's negative power, it doesn't like it where it is. It wants to be up in this case. It's down. It's sad. It wants to be up. Now it's going to be happy, right? So here, does the 7 squared like it down here? No, it's negative. So what's going to happen with this? It's going to flip. So the 7 squared is going to flip, and I still have to square it.
Is it a negative square anymore or no?
Negatives.
No.
No?
Sort of the same reason why, if I wrote this, what's wrong?
No.
Is that square still there?
No.
It's done its job, right?
Oh, okay.
So I don't write the negative still because it's done its job. It flipped it. Otherwise, when would it stop flipping? 3 to the -1 is 1 over 3 to the -1 is 3 to the -1. It's like, good God, it's never going to stop.
It's like how to keep it in.
So it's got to like it somewhere. If it doesn't like it on the bottom, it likes it on the top, right?
So if the 4 was negative on the top one, so it stayed negative, and then the 7 was positive, so we don't have to worry about that, but does that make sense? Like,
A negative power means flip. This 4 happened to be a negative number. A negative power only means flip. That's all it means.
And then the power
So the
goes to
base
positive,
stays
but
the
the
same.
number stays
I like
the same?
Unless, when the flipping, the base stays the same.
Okay.
And then, of course, you apply whatever power is still there. I like it.
so if the 7 was negative, it would stay negative.
Mm-hmm.
Okay. Makes sense.
What about this here? I like this one. It's a little bit evil, but that's all right. What do you flip? The 3,
One.
right? Is that affecting this? Is that power affecting this negative sign? No. Right? It's a lot like, so this is really what's going on here. If I have, what's the difference between these two things? Is there any difference between those two things? Yes, they are different. One's got parentheses, the other one doesn't, for one thing. But does that change the math of it? Yes. What's being squared here?
And then
No. The 2. That square is not mega powerful. It's on. What is that square on? It's on the 2. What is this square on? The -2. Right? That's why these guys are very often called grouping symbols. They help group stuff. That power can only go so far. I've seen people do this. Can you guys see why this is wrong? Why is that wrong?
Is that hard?
The 2 is not being squared, is it? What's being squared? The x. Same thing here. Is that negative being squared? The 2 is being squared. So how do we write this? What's 2 squared? 4. So look here. What's 2 squared? 4 with a negative in front of it. Now what's this come out to be? Positive 4. Yeah. Good. So this does not break the rule that when you square something it comes out positive. It's got a negative sign on it, right? What is 2 squared? It is positive 4. But then you put a negative in front of it, so it's negative 4. Okay. That power can only go so far. All right? It's the same exact thing as this. Why that's wrong. That square can only go so far. I'm squaring the x, not the 2. Okay.
Kind of makes sense.
Kind of. Okay, I can live with that for right now. So here's some problems right out of the book here. Actually, I tell you what. Let me put this up on the overhead. I moved and I misplaced this thing. I finally found it again. Okay. All right. So here's some problems I want you guys to work on. Now, I mean, when I'm talking about the idea behind something, as a student, it gets a little bit confusing as to what you're going to have to be able to do. So I want to take a break right now and try to get you guys to do a few problems to see what it is you're actually going to have to be able to do. So, I mean, if I had, for example, x cubed times x to the 5th, what's that?
X to the 8th.
x8. If I had x to the 11th over x to the 5th,
X to the 6th.
x to the 6th. So what's important for you right now is to internalize those properties. When you multiply like bases, you add the powers. Divide like bases, you subtract the powers, and so forth. Those basic properties are what you have to be able to apply. So you try these out. 68. If you have the little booklet with you, page 68. I think the hardest one up there is going to be number 7. Just to let you know. If you hit that and you're like freaking out, you know ahead of time that's going to be harder. The rest of them shouldn't be too evil. That's my hope. Yeah. Oh yeah, you got your little here, the little carrot. So if you do 4 to the 7th. So that's your two, what it calls a 2 to 11. Yeah.
What?
Some calculators have a different symbol. So you guys can work together on this. You can call me over if you need some help. So like, watch this. Move it this way.
Now number 3, 2.
Well, I can do it, I just forgot my calculator, so I don't want to.
Reorganize these 2 times.
What do you have in mind?
So now you got A7 to A3, so the A is going to end up being
Yes, if you multiply those two.
Times these together.
40.
You're trying to show like it's in there.
Since they're both A's, you can just do the same thing, I think. It's still 10 minus 4.
Was it 10 times -4?
I don't know. I don't know, we're not gonna calculate it, so.
You don't need to come out with the whole big ass number. Just apply the properties of exponents. So if it's 3 to the 10th, leave it 3 to the 10th or whatever. Don't give me, whatever the hell the big number is.
What would you do on, do you times everything?
So watch this. Here's what's this? No.
I don't know.
It's 2x
6x.
times 3x.
Okay,
It's
times
not 6x. 6x squared. Right?
Why?
Because you can, it's multiplication, right?
Yeah.
So you can move the 3 over with the 2. And you can move the x's together.
Okay.
Would you actually write that out? No, of course not. when you multiply whatever order you want. So we're gonna multiply the 2 and 3 and the x and the f. You do exactly the same thing here. So now you got more a's. Right there, I just had one of each x. It's the same idea though. Same idea. Oh, yeah. Yeah, except just one little thing should be negative. But otherwise, oh, and how many a's do you have total? Exactly.
Why is it 10? -21. Because you still have them? You're not multiplying them?
You are multiplying the a's, but keep this in mind. A to the 7th by itself means this. So if I multiply by that a3, doesn't that just really add 3 more a's there? What's being
How would you even write that in here, Jeffrey? What was that? Graphing? No.
No. So it's just distribution. So you cube each one. Exactly. So each thing gets its own cube.
This is stupid. Can you do it?
Exactly.
On your calculator?
Yeah, except this would be actually higher.
I got -48 to the power of 5.
Times another 5 would be 1. That's the right, that's the right idea. That's the right idea. So real quick, remember cubing? You're not adding those, you're just multiplying. So you do 10 times negative. Not 10 minus 1. The a's are fine, because you're multiplying, so you add the exponents. So 5, you have a power. What's that cube going to? What's being cubed? All of them. So each one gets a cube. You just distribute that.
Would that be the answer that?
Yeah, that's it. So right here, 5 groups of 6 y's. Yes.
How do you do number 6?
Number 6, I would like.
Do it in the calculator.
I would write out.
In the calculator. But you don't have like that.
But there's a quicker way to do it. Each one gets raised to the 4th. Distribute. 1 to the 4th over 3 to the 4th.
You can put it into a fraction.
And 1 to the 4th
Like you
is
press
what?
the number and it puts it into a fraction.
Careful now. 1, exactly. Over 3 to the 4th.
It's not right. Oh, okay.
Cool. Oh, let's see. All right, guys, let me try to catch up to you. So up here. Wow. This one's nice, right? Hopefully. What do you get?
3 to 13.
I love it. So we're past the stage of saying 9. None of us will ever say 9 again there because I don't have any 9s. I have 6 3s, 7 more 3s. I got 13 3s multiplying. Because exponents keep track of how many I'm multiplying. When I multiply more, my exponent gets a little bigger because I'm multiplying more. Okay, so is that cool? Any questions on that one?
No.
Okay. You're all like, make all of them like that, Jeff. I can't. It's too bad. Here, this is the same idea, just one more.
20.
Yeah, you just add, keep adding. I'm multiplying, got 5 n's, 6 more n's, and then 9 more n's after that, so I got 11 plus 9 is n to the 20th. Sweet. Okay. This one is the first one that gave us some trouble, and what I was showing people for number 3 was this example here. If I have 2x times 3x, what is that? It's not 6x. 6x squared. Why are you allowed to do that?
Because x's are being multiplied.
Not because of the same base, because it's all multiplication, right? I can multiply whatever damn order I want to. So I'm going to be smart. I'm going to multiply the 2 and the 3 together because I can. And I'm going to multiply the x and the x together because I can. So that's where your like base comes in. So you're right. Part of it was like base. So here it's the same idea, just larger powers. Who cares? What are you going to multiply together? Because you can. The 10 and the negative 4, you multiply those, you get negative 40. 7a's here times 3 more. So you got 10a's. Right? How we doing? So don't make more of it than it is. When you multiply, if you have nothing but multiplication, you just multiply your numbers together. And actually, I can make a problem. Let me see if I can make a little side problem here. You guys say, well, we know you can, Jeff. You've done it before. So if I had 3a squared b7 c9, I like it already, times negative 2a cubed b negative 3 c8. Now, this is where I want you to realize, this is where the people that are naturally good at math are just the people that were lucky enough to be able to break things into its parts. So the people that look at that and they don't look at the whole thing at once. And I happen to be one of those lucky people. I was just lucky. That's just the way I look at things. So I see the 3 and the negative 2. I don't see any other shit up there. Because the 3 and the negative 2 are the only things I can do something with immediately. Right? 3 times negative 2 is negative 6. Now I move on to the A's, the B's, the C's.
And that's when you would multiply the exponents?
Well,
Add them.
No. A to the first.
what operation? What operation is going on? Multiplication. So I have to add exponents, exactly. So it'll be a to the 5th, b to the 4, because 7 minus 3 is 4.
And then we see the 17.
I can't write when I look up there. And then c to the 17. So this is what I mean by don't make too much out of it. This is how you attack it. You attack it with numbers and then the letters in alphabetical order. So I can make this long-ass problem and you really don't care. It's just going to take another minute to write out. Just numbers and then A's, B's, C's, whatever. Just keep adding those exponents. Number 4. I like it.
Y equals 30, or y
Why
to
did the
30.
30?
I like it. Cool. It's not 11 up there, right? This is where you have 5 groups of 6 Y's. That's the definition of multiplication, right? If I had 5 crates and each of them had 6 apples, I've got 30 apples. That's really what, if I have 5 things, each of them has 6 Y's, I got 30 Y's. Number 5 is the one that really gave us some trouble.
5 to the third.
But this is just that power distribution. Right? So yeah, 5 cubed, x
To the third.
cubed, y cubed. Nobody can escape. What's being cubed? Each of them. So how do you write it? Cube each of them. Now what happens to being 5 cubed? Did anybody get that? 125. So I'll try to be on a test or something, I'll try to be specific when I want you to give me the actual number. Because if it's 3 to the 11th, like I was saying earlier, don't make 3 to the 11th into its number. That's sort of getting crazy. But if it's 3 squared, write that as 9. 5 cubed is kind of getting on the edge of that, but we should know some of these cubes. And over time, we're going to learn what 4 cubed is, what 5 cubed is. You're going to know it automatically. Same idea here. What's being raised to the 4th power?
Each number.
Each one. So I get 1 to the 4th over.
1 to the 81. 1 over 81.
I like it. 1 to the 4th is 1. In fact, what's 1 to the any power? 1. Because you keep multiplying 1 by itself. You never get anywhere. 3 to the 4th.
12. No.
Not 3 times 4, 3 to the 4th. So 3 times 3 times 3 times 3. 9 times 9.
81.
Exactly. Cool. So everybody's saying 81 over and over. You're right. I wasn't
If 4 was negative.
ignoring it. Huh?
If the exponent was, if it was negative 4.
You would have flipped it first and made it 3 to the 4th. Right? So if I had, the problem would have been this. Don't look up there, Jeff. If it would have been that, the first thing I would have done is done what the negative power tells me to do. So what do I get when I flip 1/3?
3/1.
I get 3.
Would it be negative? Oh, yeah.
To the what power now? 4th, because you've done the negative power. You've already done the negative part of it. It's done. It's gone.
Then it would just be 81.
Then it would just be 81. Think about why that makes sense. If 1/3 to the 4th is 1/81, 1/3 to the negative 4 should be the flip of that. 81. It makes sense. A negative power flips what you normally get. Okay, so a couple left here. Now this was the one I said would be the hardest one.
You still distribute the 3 to
Definitely. You
everything?
first, what does order operations tell you to do? Do you multiply first or do you exponent first?
Exponent.
Exponent. So can you do anything inside the parentheses? Good point.
No.
No, so I can't do anything inside the parentheses. The next thing I do is exponents. So what am I cubing?
2 and then that.
So it's 8.
So it's
Good.
6.
2 cubed is,
Oh,
6 to the.
no,
it's 8.
8. 2 times 2 times 2 is 8. And x to the what now?
The 5th.
Careful. 6.
Six.
So see, I totally understand that it's really easy to make the mistake. When do I add? When do I multiply? Right? But you only add them. Exponents are based on multiplication, so they can only change when you multiply things, right? When I raise something to another power, that's when I'm getting 3 groups of 2 in this case, and that's multiplication. That's the definition of multiplication. So I got to multiply that, get 6. So that's the first piece. What's this guy? X to the 12th. I love it. You multiply, right? With me? If it was this, what would it be?
X to the 7th.
X to the 7th. That's when you add. If it's this, x cubed to the 4th power, that's 12. What's 4 groups of 3 x's? 12 of them. There you go. And now what's the last step? 8 times 1 is 8. There's understood 1 there, right? If you want. And how many x's do I have now?
Would be, we just multiply that. So
18.
18. You add them.
8 to the X to the 8.
I'm not raising something to a power there. I've got 6 x's times 12 more x's is 18 x's now.
Okay, so there's no exponent on there, either one, that's when you add them, even though they're in the parentheses, they're not an exponent, so you add them.
You are multiplying like bases, so you add. Cool. And finally, this little dude. First thing I would do, and you don't have to do it this way, but to me it makes the most sense. I look at that power as being 2 instructions. Flip it, and then you still have to cube it. It makes it so much easier to look at negative powers. So I first flip it. What have I not done yet?
4 to the
Cubed
3rd.
it.
And you only cube the 4, not the whole thing?
Because what's the only thing we raise to a power in the first place? 4.
Well, even if you do the raise of 1.
Even if you do, exactly.
Yeah.
You didn't really want to go there, but even if you do, it doesn't matter. But really, the true reason is, the only thing we can raise to a power right there is 4. So you flip the 4, what do you still have to do to the 4 if you do that? You still have to cube it. And I love looking at it that way, because it matches with the math. That way of looking at it is exactly what the math wants. And what happens to be 4 cubed? 64. 4 squared is 16, times another 4, 64. Cool. Okay. That was too much fun. Let's do some more. And then we'll take a break. Right, so a little break in your future will help you hopefully get through this.
So the answer to number 7 was 8x 18, wait.
Oh, sorry. The answer to which one?
Number 7 was 8x.
7 was 8x to the 18th. So let me see what you guys think about these 4 here. And then we'll take a break. Oh, cool.